All right, this is Precalculus. We're in chapter 8 on lesson 4. So let's begin on page 547 in your textbooks. So now we're going to look at practical examples of when a trig equation would be appropriate. And so we're going to look at some real life situations where we can actually write a sinusoidal equation or function to represent what is actually going on in the real world. All right, but first I want to remind us about the sinusoidal equation. So let's just look at the sine function. So say f of x equals a times the sine of bx plus c plus d. All right, that's our standard equation. Remember what this a is, right? You remember that? It's the amplitude. The amplitude is how high above your x-axis and how low below your x-axis the curve moves. And you can actually use, so this is thinking about the y values. You could do the max y value minus the minimum y value, and you take half of it, divide it by 2. So you can get your amplitude. And remember, the amplitude is always the absolute value. There's not a negative amplitude, because that negative, remember, is a reflection, right? It's a vertical reflection across the x-axis. All right, so that a value, the value in front of the sine or cosine or tangent, is always your amplitude. The b value. The b value helps us determine the period. The b value tells us how many cycles between 0 and 2 pi that the curve completes. So b helps us to calculate the period. And remember, the period is 2 pi over b, right? So I want us to go ahead and connect these. Period is really close to like time. The time it takes to complete one cycle, because we're about to get into distance equals rate times time. All right, the distance for one curve is always 2 pi, right? Right. And so period is the time it takes to complete one cycle. All right, what does the c value tell us? The c value is our phase shift. That moves it left or right. But remember, we have to factor the b out. So the phase shift is literally c over b. You have to factor that b value out. And that is a shift left or right. I should have put a minus here, right? Because that's the standard equation. If it's minus a c value, then it's to the right. If it's plus, it's to the left. All right. Now, the d value. The d value, it's a vertical shift up. That literally moves an imaginary x-axis up or down, such that the curve doesn't even have to intersect the original x-axis. All right, so it determines our x-axis. Positive is a vertical shift up, negative is a vertical shift down. If we have the curve, then we can do maxes and mins and determine how it's been vertically shifted. So for the amplitude, we subtract, divided by 2 to get the amplitude. But for the vertical shift, we are going to add the max and the min. So it's the max plus the min and divide it by 2 to get how it's been shifted up or down, all right? Got it? You're remembering? I know you got to shake those cobwebs out, huh? All right, so let's look at example 1 on the bottom of page 548. All right, when you look at that sinusoidal function, remember, the sine curve begins at 0, goes up to 1, back to 0, down to -1, and back to 0. When I look at that curve, when the x value is 0, it doesn't start at 0. It's up. So automatically, I think it's the cosine function. Visually, I look at it, it's the cosine function. So if I'm writing a function for it, I'm using the cosine, all right? So f of x, and I'm going to use the cosine, all right? Then I'm going to look at the amplitude. The amplitude is going to be out front. All right, so the amplitude, I can take the max y value minus the max min value and divide by 2. All right, so the max y value is at 4, the min is at -2, and I'm subtracting them. So it's 4 minus -2 over 2. 2 negatives make a positive, so that is 6 divided by 2, which is 3. That's my amplitude. My amplitude is 3. It's multiplied, all right? Now, I need to calculate the period. Okay, to calculate the period, you just need to look at when the curve begins and ends. Any curve at any point. All right, so let me just show you. When we're looking at this, look at my iPad. If I can do this, I can. Look, I see it begins here and ends here. So that distance is pi. I could go bottom to bottom, right? But to me, it was easier to go here to here because it was just pi. All right, so what does that tell me? That tells me the period is pi. It takes the distance of pi to complete one cycle. That does not give me the b value. I have to calculate the b value. So if the period is, I said pi, then because I'm using the cosine curve, it's going to be 2 pi over the b value. All right, so it's 2 pi over the b. All right, you remember, you can swap your extremes, right? So that's all I'm going to do is swap my extremes. B is 2 pi over pi, right? I swap those. My b value is going to be 2. So I'm going to have already divided. I'm going to have to calculate C, and then I'll move 2 back in, all right? We'll move 2 back in. I used X, so we'll use X. All right. Well, has it been shifted left or right? There is no phase shift. No phase shift, because it starts at 0. Okay, so I didn't even need that. It can just be 2x. 2x. All right. Has it been shifted up or down? So there's no phase shift, left or right, right? Because it begins at 0. What is the vertical shift? Yes, there is a vertical shift. I know it's up, so I'm going to add. And I can tell, you can tell visually, it's been shifted up by 1, but let's use the formula. So I know I'm going to add 1. Max plus the min divided by 2. So it's 4 plus -2 divided by 2. That's 2 divided by 2, which is 1. And I already can see it visually. All right, so that would be the cosine function. All right. Now, if I were writing the sine function, then I remember it goes up first, then goes down. all right? So if I'm writing the sine function, we did the easiest one first. I would say my sine function begins here. So that's a phase shift, right? That's a phase shift right by 3 pi over 4. All right? So that's the only difference with the sine function. All right, so it would be f of x. My amplitude is going to be the same. The sine now is when I am going to do the 2, and it's going to be x. So I know the phase shift is 3 pi over 4. It's to the right, so it's minus 3 pi over 4 plus 1. If I factor that in, I'm just multiplying by 2. So it'd be 3 times the sine of 2x minus, it would really be 6 pi over 4, which is 3 pi over 2, simplified, plus 1. All right? So first write the easiest one and then think about what the other one would be. Now there are 2 more examples, and we're only going to write either the sine or the cosine. Remember, period is time, but we always want the b value. All right? So look at example 2. All right, distance equals rate times time. Our distance is going to be 2 pi all the way around, right? It's 2 pi, all right? Because we're talking the unit circle. All right, so look at example 2. It says, this is on the top of page 550. It says a wheel with a radius of 2, all right? So the radius is 2. All right, so think about that, the radius. The radius tells me how high up I'm going and how low down I'm going. So really that's just my amplitude. So I know my amplitude is going to be 2, right? Because as I move that wheel, the wheel's going to go up to 2, back down to 0, down to -2, back up to 0. Literally, here's what we're going to do. We're going to calculate the movement from the base of the bar. So I'm going to go up to, around, right, down to, and back. All right, but the movement is in the wheel. It's not really square like I said it was. Okay, and it's rotating counterclockwise at 3 radians per second. That's the rate. 3 radians per second. So remember, time is your period. So we're going to solve for time, and that's going to be our period. All right, so 2 pi equals 3t divided by 3. All right, so my period is 2 pi over 3. All right, time, same thing as period. Okay? All right, so my period is 2 pi over 3. Remember, to find the b value, we set that equal to 2 pi over b. Well, the b value has to be 3. All right, so I have my a value. I have my b value is 3. And the only other transformation that has happened is this rod, this free hanging rod. It's 10 centimeters long. It's connected to the wheel and remains vertical. All right, so that's a vertical shift down. That's where our movement is going to be in that rod. It's going to go round and round. That rod is literally going to make a circle, right? So that's a vertical shift down by 10. All right, so now I can write the equation. All right, f of x. Okay, now let's look. We have to decide sine or cosine. It's not the tangent, obviously not the tangent. All right, so look what happens. The rod's going to go up first, back to 0, down, and then back. So here's what I'm thinking. Up first, back to 0, down and back to 0. So I am thinking sine, all right? So it's the sine. The amplitude is 2. My b value is 3. It's going to be 3x. It's vertically shifted down by 10. All right, so now it asks, that's A. Because it says find a function that describes the y-coordinate of the tip of the rod. All right, that's why we're vertically shifted down. All right, B. What is the first time that the tip E of the rod will be at a height of -9? That's our y value, right? F of x represents the y value. So set all of this equal to -9. So we have -9 equals 2 sine of 3x minus 10. All right, add the 10 on both sides. And you have 1 equals 2 sine of 3x. Divide by 2 on both sides. So you have the sine of 3x is 1/2. All right, we're going to say 3x is u. All right, 1/2 is on the unit circle. All right. It's positive, so we're looking in the first quadrant because it just wants to know that first time that it hits it. Okay, so remember, the sign starts at 0 and counts up. So it's 0, 1. So it's that very first radian measure on the unit circle. So it is at pi over 6. So literally, u is pi over 6. That's the first time. Now we can do plus minus 2k pi, right? But we just want the first time. All right. But I want to know x. I don't want to know u, right? Oh, they did plus 2k pi. I thought it just said they wanted to know the very first time. What is the first time that the tip of the rod will be at the, okay. We're only going to answer the first time, even though in the textbook it says plus 2k pi. All right. So now we're going to put back 3x is pi over 6. Because I have a fraction on the right-hand side, normally we would divide by 3, but I'm going to multiply by 1/3 on both sides. So x is pi over 18. That is the very first time it is going to be at -9. They didn't want to know every time, right? And that answers that question. There we go. All right. Got it. Distance equals rate times time. Time is your period. All right, so let's look at the next example. We're only going to go through example 3. All right, so this is on page 551. Example 3. All right, so let's look at it. So suppose that a weight is hanging from a spring that is set in motion by pushing upward first. Okay, so it's going to push upward, come back down, and go back to equilibrium. So it starts at equilibrium. We're going to push it up, come back down, go below equilibrium, and come back. That's the sine curve, right? We go up first, back to equilibrium, down, and return back to equilibrium. So I am thinking definitely we're using the sine function. All right. It takes 5 seconds. What is that? 5 seconds. If we say distance equals rate times time, what is 5? 5. Five is the time, right? What is time? Time is the period. So our period is 5. Got it? It takes 5 seconds for it to complete one cycle of moving from its equilibrium position to, okay, now it's going to give us the amplitude. 8 centimeters above, then drops 8 centimeters below. So that's our amplitude. Okay, that's our period. Our amplitude is 8. We don't have the B value, but we're going to use that to calculate our B value. Doesn't look like that it's been shifted to the left or the right. So there's no phase shift. All right, so we're going to do 8 times the sine, period. Remember, period equals 2 pi over b. We've got to get the b value to put in the equation. So 5 equals 2 pi over b. Now remember, we can swap our extremes. That's what I'm going to do. B is 2 pi over 5. This is my b value. All right, I just swapped my extremes. So it's going to be 2 pi over 5x. Not been shifted left or right. All right. So that's the function. You could sketch it. If you look on the next page, you can see a sketch of it. It just goes up, down, doesn't even give you the periods, right? But it's going to complete one cycle at, it's going to take 2 pi over 5 to complete a cycle. But they didn't even label that. All right, now, well, actually, look, they did. It's 8. I was looking at the wrong one. Look, it's this image right here. It completes it at 5. That's how long it takes. And they just divided it 1 to 5. Okay, remember, pi is a real number. All right. Now, C. Let me go back and read C. All right, use the function to predict the height. That means the y value. Predict the y value. Remember, height is on that y-axis after 3 seconds. All right, and our seconds are on the x-axis. So we're just going to plug in for x 3, right? That's what it said. F of 3 is 8 times the sine of 2 pi over 5 times 3, which is really 6 pi over 5. You can put that in your calculator. This is 8 times the sine of 6 pi over 5. All right, I'm going to do the sine of 6 pi over 5 first. Make sure, again, that I'm in radians, and I am. And then I'll multiply by 8. All right, so it's the sine of 6 pi. I want to put that in parentheses. 6 pi divided by 5. Divided by 5. Close. All right. So that's how I put it in my calculator. So I get, just for that value, negative, so it's going to be 8 times that value. It's going to be 8 times negative 0.5878. I'm just going to multiply this by 8. And we get, so f of 3 is negative 4.70. They just went to one decimal place. All right. Now look at D. In the first 5 seconds, when will the height of the weight, that's our y value. When will the height of the weight be 6 centimeters below? 6 centimeters below. So that's at negative 6. All right, so I'm going to go back here Now we're solving for the x value. It's going to give me the y value at equals -6. All right, so we're going to do the same thing. We're going to divide by 8 on both sides. So we have the sign of 2 pi over 5x equals, 2 goes into both of those, -3/4. All right, now we're solving for x here. So I'm going to do the inverse sign. All right, this is one piece. You cannot separate this. So I'm going to do the inverse. Remember, when I do the inverse for the sign, I'm in quadrants 1 and 4, right? 1 and 4. All right, so I'm thinking 4, you know, just below, because that's negative, we're going to be in the 4th quadrant. All right, so -3/4 equals 2 pi over 5x. All right, so this I can do in my calculator because 3/4 is not on the unit circle. All right, so I am going to do that, shift sign, -3 divided by 4, and I get -0.8481 equals 2 pi over 5x, but we're wanting to solve for the x value. So I'm going to multiply by 5 over 2 pi on both sides. So I'm going to multiply this by 5 over 2 pi. So that value will multiply by 5 times 5, and then I'll divide by 2 times pi. I'm putting that in parentheses. So my x value is, I'm looking, -0.67. Wait, did I get that right? Is that in the 4th quadrant? It's negative. I want it in a, okay. Before I do this, I have to remember, this is in the 4th quadrant. I'm going down. I really want it in positive. So I'm actually going to take 2 pi and subtract 0.8481 before I do this, because this is a positive number. All right, so I'm going to convert this. Okay, let me explain that. They're saying this distance is -0.8481. I want the positive distance going in the positive direction. Otherwise, I really can't calculate x because I'm going backwards. All right, so I'm going to take 2 pi, which is all the way around, right? I'm going to go 2 pi and subtract that to get the positive value. So 2 times pi, then I'll subtract 0.8481. All right, so that's 5. This value here is 5.4351. So I converted that to the positive. I neglected to do that first, but you need to first convert that to a positive. Now, I know that that is in the 4th quadrant, right? So I'm going to now multiply it by 5. I have this 5.4351 equals 2 pi over 5x. That's in the 4th quadrant. But you have to remember, there's also a value in the 3rd quadrant, right? So we're going to think about that in a minute, all right? But let's figure out x in this quadrant. So I'll multiply by 5 over 2 pi. So it'll be times 5, which equals divided by 2 times pi. And that's x equals 4.3251. That's the one in the fourth quadrant. All right. So remember, I need one in the third quadrant because it's all students take calculus, right? And the sign is also negative in that third quadrant. So remember from the previous lesson, let me erase some of this at the top. We said the sign of x is the same exact value as the sign of pi minus x. So I've got this value, which is the 5.431 positive. All right, so in the third quadrant, I'm going to go back here, I'm going to do pi minus that value. Actually, I'm going to take this value. I'm going to figure out, I'm going to take pi away from it. Pi, that's not going to be enough, is it? Let's do pi minus that value, which is plus. Remember my calculator was doing weird stuff earlier? I'm going to do, if this is the angle, I'm going to do pi minus a negative or plus 0.8481. So pi plus 0.8481. And that is 3.9897. All right, so I had two equations. I'm going to go back and write this on the board. All right, I originally got negative 0.8481 equals 2 pi over 5x. I wanted to make that positive, so I took 2 pi and subtracted that, and I got 5.4351 equals 2 pi over 5x. I multiply by 5 over 2 pi, 5 over 2 pi. I'm going to erase some more of this. And the value of x was 4.3251. Just don't have as big a board as I do at church, right? At school. Then, because I knew that the sign was negative, both in the third and the fourth quadrant, I utilized that concept. All right, so I'm going to erase a little bit more. So when I took pi minus the negative 0.8481, which is plus that, I got 3.9897 right here. All right. So now I'm in the third quadrant. And that makes sense because the third quadrant is between pi and 3/2 pi. But I haven't solved for x, so I need to go back and solve for the x value. How long? All right, so I'm going to do the same thing I did here. So I have 3.9897 is 2 pi over 5x. I'm going to multiply by 5 over 2 pi on both sides. And x is, all right, so I'm going to multiply by 5 first, times 5, then divide by 2 times pi. And x is 3.1749. All right, so what does that tell me? The points of intersection for that weight in the first 5 seconds, when it'll be below the equilibrium, are at these points. At 4.32 about, and at 3.17. That many seconds. And are those seconds between 0 and 5? They are. All right.